Well, good afternoon, everybody, and welcome to this month's edition of DBA Fundamentals Down Under. My name's Warwick Rudd, and I'm hosting this session for you today. In today's session, we've got Brandon Leach coming and talking to us about partitioning basics, treating your tables like Lego. Now, before I hand over to Brandon, just got a couple of slides to go through and some housekeeping, but I won't keep you long before I hand over. So first off, we've just want to call out to our sponsors, Century One. Without our sponsors, it would make it difficult for us to bring these sessions to you. So if you aren't already using Century One products, make sure you go to their site and have a look at their free downloads and their products. They produce some fantastic products that help you in your SQL Server environment. So make sure you go there and have a play with their products. Now, all of these sessions are recorded and will be made available up on the DBA Fundamentals archive page. They will normally become available a couple of days after the session based on timings for us to work through the recordings. So you can come back and watch these at any point in time. Before I hand over, I just want to make a big call out to those of you in the local area about some upcoming SQL Saturday events. This coming Saturday in Sydney, if you haven't already registered, we've got SQL Saturday Sydney. We've got SQL Saturday South Island on April 8, and on May 27, we've got my own SQL Saturday here in Brisbane. So feel free to register and come along to any and all of those, and you'll have a fantastic day learning from some great local, interstate, and international speakers. So with that, you guys are here as part of PASS. There are many other virtual chapters that you can be a part of. So go to the PASS website, make sure that you have a look at the other virtual chapters that are available, log on to and register for some of those because there are fantastic sessions available to you to learn from some great speakers as well. So with that, I'll now hand over to Brandon and he'll be able to take us through this afternoon's session.
All right, thank you, everyone. Everyone see my screen?
Yes, we can see your slide deck.
All right, perfect. So my name is Brandon Leach. I'm a senior DBA at SurveyMonkey. We're based out of Silicon Valley, San Francisco Bay Area. I've been involved in IT for 15 years. I'm fairly heavily involved in the community as well. I do a lot of SQL Saturdays, user groups, question and answer forums, etc., and was recently in October of 2016 awarded Data Platform MVP. If you need to reach me, have any questions that you forget to ask or don't get a chance to, you'll find my contact info here on this slide. Feel free to reach out to me. I am happy to answer. And my email is just brandon@sqlservernerd.com. So we're going to talk about partitioning today. So we're going to start off with, obviously, what is partitioning. Then we're going to talk briefly about the different types of partitioning. Horizontal versus vertical, what does it mean? Then we'll look at how how partitioning was done in SQL Server 2005 or prior to SQL Server 2005, and how it's done today. In other words, what's changed, what techniques do we have available to us. Then we're going to blast right into the table partitioning feature itself. We'll talk about partition function schemes, what is an aligned index, when might it be useful. We'll also talk about how partitions make management easier and how we can use these partitions to our advantage, both in regards to standard database maintenance as well as talking about what's called a sliding window. And we'll see demos on these things as we go. So what is partitioning? Partitioning is the process of breaking things down into smaller chunks. At SurveyMonkey, we do partitioning at a very high level. We actually have multiple databases that contain our data. They're same schema, just different rows go into different places. For example, we have certain users who are on one shard whose surveys only exist in a certain shard. But in terms of SQL Server, we have two types of partition. We have horizontal partitioning and vertical partitioning. Now, vertical partitioning in a table could be thought of as splitting out columns into a separate table. We might do this to make our tables smaller and thus get a higher page density, more rows per 8 kilobyte data page. Horizontal partitioning is typically what we think of, though, when we're talking about partitioning in SQL Server. This is the process of splitting rows into different buckets. So instead of cutting out columns, we're saying these rows exist in this bucket, those rows exist in that bucket, and that's really what we're going to focus on today. Now, I will be taking a break at certain points for questions, so please send those over to Warwick using the question pane. But let's talk about how partitioning was done prior to SQL Server 2005. Because there was no partitioning feature per se. We really had to roll our own solution. And the common one was this thing called a partitioned view. The long and short of it is we would create separate base tables. Those tables would have the same schema. And we would apply constraints to those tables such that they defined what those individual base tables were allowed to contain. So we might have a table with a constraint that says only October of 2016 can exist in this table. And the next table may say only data from November of 2016 can exist in this table. What we would then do is we would add on a view. And that view would do a union all, and it would then, when we queried that table, the optimizer would be smart enough to actually do what's called partition elimination. And let's actually see that in action. Oop. There we go. So the first thing I'm going to do, I've got my sample database here. And by the way, I'll be sending Warwick all the script files you'll see today so that you can actually play around with this stuff. So what we've got at the top here is we've got this all orders view. And you'll see that all it really does is join two tables using a union all. So all the rows from current month orders and all the rows from orders archive. Now you'll also notice I've created a few separate schemas here, in this case the PV schema for our partition view example. That's to make life easier for anyone who wants to play around with this. We've also defined our constraints down here. And as you can see in this example, orders archive can only contain data up through the last day of October, whereas current month orders can only contain data greater than, well, in our case, November 2nd, 2013. Now, constraints are great. When I query all orders table, I'm going to show the actual execution plan here. Oh, actually, sorry. Here we go. What we're going to see, there we go. All right. So if we look at our query plan here, well, what we're going to see is that we do a table scan against current month orders and a table scan against orders archive. That's fairly normal. But when we go here and we select this specific date, an interesting thing happens. So we queried for the 30th of October, 2013. And you'll notice SQL Server didn't actually scan the current month orders table. The reason for this is because the query optimizer actually looked at the constraints on the table and realized it didn't need to touch current month orders. Current month orders couldn't possibly have any data for it. So it excluded it. And by the same token, if I go down here and we query for November 2nd, what we'll see is that now we've reversed the situation. Now we're just hitting the current month orders table. This is called partition elimination. This is SQL Server using the information we have given it to make better decisions and generate a better plan. Now, if you noticed when I defined my constraints, I actually left out a date. There's no possibility that either table could contain data for November 1st. This has an interesting effect. When we run this, what we find is we get back the easiest query plan ever. SQL Server literally looked at the constraints and said, I have nothing to do. So it didn't hit either table. And that's really cool. The query optimizer is really smart. And this technique, even with table partitioning, you'll still find this technique in use today. In fact, we here at SurveyMonkey, we've got several partition views in place. Now, table partitioning itself, the reason I like to show partition views and instead of jumping right into table partitioning is because not everyone is on Enterprise Edition. And for the longest time, this feature was an enterprise-only feature. In fact, that changed only about a month or so ago. So, as of SQL Server 2016 with Service Pack 1, you can now use table partitioning in Standard Edition. So if you're considering upgrading to Enterprise for table partitioning, or any of the other features like in-memory OLTP, which are now in Standard Edition, you now have a cheaper route, a far cheaper route to get the features you want. Now, table or partition views are great, but they're not perfect. They're not transparent. Developers need to be aware of what's going on. And so that makes things complicated. So, table partitioning allows us to kind of get by that. It's completely transparent to the queries that are being run. It's more complex, though, in its implementation. We have to put more effort into it. So we're going to have to talk about things called partition schemes. Now, before I move on, let's discuss what a partitioned table looks like versus a typical table. So let's talk about data files and file groups. So anytime we create a DB, we always have a default primary file group that gets created, and it always has one data file. File groups are just a container for a group of data files. And with partitioning, we can do things like send different parts of our table to different tiers of storage. In this case, we've got two file groups. So we've got the primary file group, and we've got a user file group. The user file group has two data files. Now, when we build a table, in this case, our table is employee. We build it on a file group. That's why when you script out a table, at the bottom of the definition, it'll say on primary. It's building it on the primary file group. And so our table is built on a file group which contains multiple data files, one or more data files. But things change with partitioning. With partitioning, our table employee is built on what's called a partition scheme. This partition scheme splits the data across file groups. So we can say, this partition goes to this file group, and that partition goes to that file group. Then we can also, then we are able to actually split out our data and put it in different places. It's common to have, older data on slower storage. Maybe we've got some 10K RPM disk, but we want our newer data, which is more frequently accessed on SSD. We can do that. So before I move on, do we have any questions at this point?
None at this point. So guys, if you've got any questions, make sure you throw them through and we'll keep a track of those.
Perfect. All right, so how do we take advantage of things like this? Well, the first thing we need to decide is how we're going to partition. What is the column and boundaries that we're going to define? Now, it's important to note that when you're partitioning a table, you need to have a clustered index on that table. It's also important to note that you can only choose one column to partition on. And that's very important. Does not have to be the same column as your clustering key, but you do have to pick a column. Now, more often than not, that column is going to be a date type. So in this case, we are creating a partition function called orders current date range, and we're giving it 3 values. We're giving it October 1st, November 1st, and December 1st. There's another thing that comes into play here. So we have to define, if we've got these boundary points and we're defining these buckets, as you see down at the bottom here, we have to define where that boundary point, which bucket that boundary point falls into. So in this case, because we're defining, the first of each month, what I'm doing is I'm specifying range right. What that means is the boundary will fall into the right-hand bucket. So our first boundary is October of 2015, October 1st, 2015. So that is going to fall into the right-hand bucket, which will contain the rest of the October data. The same with November and December. We also get a bucket for data that precedes October 1st. So it precedes the first boundary we define. SQL Server will automatically create that partition. Now, if I had done range left, we would have got a pre-created bucket on the other side. So it would have, instead of having prior, we would have had an extra bucket after December 2015 because we did range left. Now, once we've defined our boundaries, we need to actually send partitions there. We need to define where our partitions are going to be stored. And so, effectively, a partition scheme, all it really does is assign partitions to certain file groups. So, file group, or our partition scheme, defines the destination. Now, it's not uncommon to send everything to the primary file group in a scenario that we're going to see later on. It's actually a very powerful tool. There's a shortcut to that. We could specify all to. So, and that would allow us to shortcut and say send everything to primary, or send everything to user FG, or whatever we want to call that file group. Now, when we build our tables, we're actually going to build them on the scheme. And you'll notice the scheme references the partition function that we created. This is important. And since, if we go back here, you'll note that that partition function specifies a date type. We're going to pass a date column to this partition scheme. Now, you absolutely should make sure that the data type in your partition function matches the column type in your table. Otherwise, you're going to get implicit conversions, and no one wants those. There's another thing that we need to think about here. Well, actually, before we move on, do we have questions about partition functions and schemes? We're going to see these in action in a minute.
So we've got one question. How do we insert data into a partitioned view?
Well, the same rules apply with partition views as they do to normal views. Meaning, depending on your view definition, you may have to insert directly into the base tables, which means your application or your stored procs or ad hoc SQL statements need to be aware of the partitioned view, that it exists, and that's what it is. So that's where partition views get messy. That answer the question?
Well, yes.
Awesome. Yeah, that's why I'm not as big a fan of partition views. I much prefer table partitioning. It gets more optimizations, and it's transparent to the developers for the most part.
Okay, so just a couple of quick ones which came in.
Yep.
So can partition views be schema bound?
Wow. When you create it, can partition views be schema bound? I've never tried. I mean, do you want to put on a materialized, or I suppose you could materialize the view? I mean, it's literally just a view. So anything you would normally be able to do with a view and all the limitations you have with a view should still apply. But I'd have to actually go and test that.
Okay. And one last question before moving on. If you have a query that only needs data from the fast disk, i.e. the recent data, what happens with the query if the slow disk partition is offline while the fast disk partition is available? Will the entire query fail?
Only if you need data from the disk that's offline.
Okay.
I mean, as long as you have that data and you're not querying against it, you should be fine. But if part of your table's missing, you're probably in a DR scenario, and so you're more than likely not going to play with this. You're more than likely going to focus on getting everything back up.
All right.
Yeah. I mean, SQL Server really shouldn't notice an issue until you actively try to get that. I mean, chances are what's going to happen is the moment that disk goes offline, you're probably going to end up in a scenario where SQL Server shuts down and your database goes suspect. Because it's now expecting data files that don't exist. Your database is not going to be happy about that. So you're not even going to get to the point where you can actually query your table because your database is effectively going to be offline in that scenario. So that's probably a better answer, thinking it through.
Okay, thank you.
All right. So now we can partition our tables, and effectively what we're doing when we do that is we're partitioning the clustered index, effectively. But we don't have to stop there. We can partition our non-clustered indexes. And if we do that on the same partition scheme, then our indexes are said to be aligned. And this grants some really nice boosts. Now, you don't have to, partition your indexes on the same partition scheme. In fact, I've seen tables that had only the non-clustered indexes partitioned. But you'll get benefits for things like equality-based joins when your indexes are aligned. And in fact, this is the default when you create an index on a partition table. It also, because partitioning allows us to do this really neat thing called partition switching, which we'll see in a bit, where we move data in and out of a table really fast as a metadata-only operation, we'll see some performances as well with our aligned indexes. Also, it allows us to do really cool things like only defragmenting parts of an index. But let's actually go into and look at how we would implement partitioning. So what I'm going to do is I'm going to go over here. And what I'm going to do is so in this script, I have done a creation of tables, partition functions, and so we're going to use what's known as the SW schema, or sliding window schema. And so our challenge is we want a table that keeps the last 3 months of data. It always has the last 3 months of data. And so we need to do a few things for that. The setup for this is I've defined this partition function. And you'll notice that this function for our orders archive contains boundaries for the first 9 months of 2015. Right? And they're all range right. Then I've defined a partition scheme. Every one of those partitions are going to the same file group. There's a reason for this. A big reason. I've also then set a new file group to say whatever the next file group that you create, or the next the next partition you create, send it to this file group. So in this case, we are going to have a newly created partition sent to primary as well. Then we do a similar thing for our current previous 3 months. In this case, October, November, and December of 2015. Right? 3 boundary points. We create our partition scheme. And if I scroll over, you'll see all to primary. That's the shortcut. And we also specify a next used for it. So we've created our objects, and we need to create a clustered index for the table. And we also need to specify what column to partition on. And so what we're doing here in this highlighted statement is we are saying build this index on the orders current table using this partition scheme, and the column we want to partition on is order date. We then do the same for orders archive. Except we build it on the orders archive data partition scheme. So when you implement partitioning on a table that already exists, what's happening is we are actually having to rebuild the table. If you don't already have a clustered index, then you apply it like I am here. Otherwise, you're going to have to rebuild it, alter the index with effectively drop and create. But we're going to skip this statement, and we will come back to this in a little bit. So what I want you to see here is we have a few system tables that give us insight into our partitions. And so what I've done is I've used the sys.partitions table, joined it to sys.tables and sys.schemas to show you the number of partitions that exist. So index ID 1, that is our clustered index. And you can see that for orders archive, we have 10 partitions. Now, you'll notice in orders archive, for the partition function, I only specified 9 boundaries. That, we still have to have a bucket, because we're using range right, that specifies, that that specifies data that doesn't fit into any of the predefined partitions. So we need a prior bucket since we used range right. Now, orders archive or orders current has 5. and I may have pre-created a bucket. And that's why, because normally we would have 4. But this script, which you'll have access to, will allow you to see the partition for any given table. In my case, I'm going by the object ID of the table that you see right here. But you could change this so that it was using the name of the table itself, since we're joining on sys.tables. There's another neat thing about this view. So if I go over here, part demo, and I'm going to go down a little bit here, because I want to show you something. If I can just find it quickly. If you've ever had to get a count of rows from a large table, you know it can be a nightmare. It's going to add locks, etc. But this table here, sys.partitions, actually has in it a row count that you can see over on the right here. And that row count, while it's an approximation, it's usually pretty accurate. If you group by the object ID, and the index ID, and then sum the rows, you will get a fairly accurate row count for your table with much less locking. In fact, it won't have to touch the table you really want to know about. Okay, so we've set the stage here. As I've said, we want to effectively move our window. Instead of what we see up here as these boundary points, what we really want to do is we want to move October into the archive table. And we want to bring in the next month into here. So we're assuming we're in January. What I'm actually going to do, because I had a bit of an issue earlier, is I have gone through this code, and we're actually going to move November in now. So we have to do a few things. One, just to verify, I usually run this statement. The next thing we have to do is actually create a new partition boundary point. In other words, we're creating a new partition. And the way we do this is with the split command. Now, split will effectively go to the very last partition and just add a new boundary point. Any data that's in there already that fits into that new boundary point will become part of it. So let's run this. Give it a minute. We're also going to, so we created a new boundary point for orders archive. We're also going to do the same for current orders, for current orders current. In this case, February of 2016. Right? Goes real quick because I had no 2016 data in there. Then we need a way to get the partition numbers that we're going to use. So if I run this, I'm just going to print it out for you so you can see. This is interesting because we don't have too many $ functions in SQL Server. In fact, this is the only one that I know of. So $partition dot name of the partition function. If we pass into that a value, it will tell us what partition that would fall into. That value would fall into. It will give us the number. And as we can see here, it says it falls into partition 3 of orders current. Then we're going to do the same thing for the archive partition. So if I run that, it's going to tell us partition 11. So what we need to do is we need to actually move partition 3 from orders current into partition 11 of orders archive, right? So just to make that easy to remember, we're going to go down here. Now, there's another thing we have to do here, and this gets a little more complex, but it's really fun. Since all of our partitions are in the same file group, SQL Server doesn't actually need to pull the data out and reinsert it. What we can do is a metadata-only operation. What this means is that SQL Server will effectively unhook those data pages and attach them to another table. And it's all metadata. And so this statement can be really powerful because it can allow us to move millions or billions of rows in a millisecond. But it only works like that if the source and destination partitions are in the same file group. Also, the schema on that table, on both tables, has to be exactly the same. They have to have the same indexes. They have to have the same constraints. Everything has to be the same. And so what people would use this for is often ETL processes. You would bring in your data, dump it into a heap table, so your inserts were really fast. Then you would actually go and you would apply your constraints and indexes to that table. And then you would use the switch command to tell it that this table, or that data in that table itself was a partition of another table. And in doing this, we're able to speed up our load processes into our data warehouse, other things like that. We're also able to do the reverse. We can take a partition and pull it out of a table and then drop it. So we could effectively truncate part of a table. Now, this actually gets easier in 2016 to do that. But let's actually run everything here. So I have to run it from here. And we're already done. We moved all the data from partition 3 in our orders current into our orders archive partition. Now we have some cleanup to do. We have to get rid of the additional partitions we created. We want things nice and neat. So before I go on into our cleanup process, do we have any more questions? I'm sure we do at this point.
Okay, so we've got one more question for you. So, can I use getDate for a partition boundary?
Well, here's the thing about getDate. You can use it, but do you want that time info in your boundary? That's something to, you can't use it as, you could use it if you were dynamically creating, using dynamic SQL, but I would not try to say in your partition function getDate. That's going to fail.
Right. So you'd
And besides, go ahead.
So I was going to say, so you'd more look at purely from a date point of view rather than a date time point of view.
Generally, yes. Unless of course you've got a scenario where at 8 o'clock, on the last Monday, you create a new partition and it always has to be at that time, and you want data after that time to fall into specific buckets.
Mm-hmm.
But that's going to be rare that you're going to do that.
All right.
So much better to just go with, data from this day is in this bucket. I've also seen people, it doesn't have to be a date either. I've seen people use in multi-tenant databases a client ID or something like that,
Mm-hmm.
so that every client has their own partition. And there's a benefit to that, because it's possible with partitioning to enable what are called partition locks. And those partition locks, instead of escalating straight to a table lock from a row or page lock, it will actually go to a partition lock the rest of the table alone, unless it needs to cross partitions. So there are some benefits to partitioning underneath the covers that we may not see necessarily, but which could be very beneficial.
So we've got one more question. So can a partition be switched out if it has non-aligned indexes?
Can it be switched out if it has non-aligned indexes? I've never tried that, but you should be able to do it. The thing about non-aligned indexes is they're going to be non-clustered indexes. So they're ancillary objects. But if you're switching it out to another table, that other table is going to need all those additional indexes on it as well. So as long as the schema matches, you're fine.
Okay.
I mean, the only time I've used non-aligned indexes is when I wanted to, is when the base table, for whatever reason, weren't able to partition it. Management didn't want to do that, but we did want to partition the indexes themselves for index maintenance. Yeah, sure. Come up with a partition scheme and function, and make sure you can rebuild the non-clustered indexes at least. But typically, you're going to want to align your indexes. Any more?
No, we're good for the moment.
All right. So now that we've created our partition, we've gone through the process of switching partitions out into a different table, we need to clean up our old partitions. And so the way we do that is through this merge command. And it's important to understand that what we're doing is we're effectively defining a boundary point here, and all data, all boundaries prior to that boundary point are merged into one. So if that's, our third boundary point in the list, those first two are coming and get merged as well. So effectively, we're compressing the partitions. Or we're compressing the number of, we're eliminating buckets is what we're doing. And so that's in contrast to split, which is always a new boundary at the end. So when I run this, it runs very quick. And so we did this with orders current, right? Well, orders archive, we would very likely do a similar thing. But not necessarily. We don't have to. It's up to us. So that's sliding windows in a nutshell. Now, in this script, what I do recommend doing is when you create your own database, take a database snapshot after you get it set up the way you want. The reason for this is then, as you go through these examples, you can actually restore your database from the snap. You can roll it back prior to the sliding window. Typically what we would do with our sliding window, which I haven't done here, is we would actually go through and we would make this a SQL agent job. And it would call functions like getDate to find out whatever the current month is, and then automatically for us determine how far back it should go and do all this work for us. That way it would be an automated process, and we would alert on it if it broke for whatever reason. Now if we go back to our slides here, let's talk about database maintenance for a minute. So we've talked about the effect of partitioning on our tables, our queries, our loads, but we haven't really touched on much on index maintenance, statistics maintenance, etc. So the thing is, with partitioning, as I mentioned before, it gives us some flexibility. If you're like us and you've got 10 terabyte tables, where running an index, a index, is just not going to happen. I mean, it's the resource usage is insane. But if those indexes are partitioned, well, we can actually check the fragmentation levels of those partitions. And that allows us to say, all right, we only need to reorg these partitions, and those partitions will rebuild, but these other ones, we're not going to touch them. We don't need to do anything. This helps us reduce the amount of time we need for maintenance drastically. And as of 2014, we actually can have what are called partition stats. We'll get to that in a second, though. 2016 introduced a minor adjustment, and this was we can now run a truncate statement and specify partitions. No need to switch it out anymore. Switch out a partition and then drop it. Now with incremental stats, this solves what was probably one of the most frustrating parts of partitioning. People wanted this for a long time. Now, keep in mind, it does not occur by default. We actually have to set an option on our indexes or on our stats objects. So the typical problem is this. It's not until 20% of a table that SQL Server generally updates the stats automatically. So on larger tables, you might have to do, with high volume of activity, you might have to do things like, restore the database somewhere, update the stats on that restored copy, then export the stats and re-import them into the source database. It's one of the things we've actually done here. Now, as of 2014, this works differently. This algorithm changes. So when we create our index, if we specify statistics incremental equals on, then it's no longer 20% of the table overall. It's 20% of the partition that has to change. And then that partition will automatically update. So the stats for that partition will automatically update. this is tremendous because it means our stats are not only going to be more accurate, but they're going to update more often. So what happens is once those stats are, that stats partition is effectively rebuilt, it will actually merge with the rest of the stats partitions seamlessly. It's great. This is possibly my favorite feature of partitioning because this will drastically improve your query plans. So, looks like we are just about done here. Let's go back here quickly. And I want to show you a query here. This will be our last transport error. Our last demo here. So what this query does is it goes through for a given table, it will tell you what the fragmentation level is on each of our partitions. In this case, we're pretty good, right? We've got very little fragmentation. We're probably going to leave this table alone. Generally, over 10%, we're going to do a reorg. Over 30%, we're probably going to do a rebuild. So how would we rebuild one partition? Well, it's that query you see right there. So if I go down here, and that is partition 6. Now, we're probably not going to get much defragmentation on this, just because it's already so low. So I don't know if it'll go all the way down to 0, but let's see. And yes. Now, there's a lot of data in that table. That table has something like 100 million rows in it. So let's run this again. And yeah, we didn't get much of any result because there wasn't much to do. So what we're left with is just some free space in that particular partition. So thank you all. Do we have any last minute questions?
So Brendan, we've got a couple. So the first one, is a index rebuild operation per partition an online operation in SQL 2014 and above?
Yeah, you can do it online.
Okay. Do you recommend using partitioning in an OLTP database?
Well, I don't look at it as OLTP versus OLAP at all. I mean, I'm partitioning for manageability first and foremost, and then for performance benefits. I look at partitioning and say, okay, well, when my tables are getting above 40 gigs, I'm generally going to start to think about partitioning. I might not implement it then, but we run a very large database here. We measure tables in terabytes. We've got 10 plus terabyte tables. We are doing about 7,000 to 8,000 transactions a second on that one database. So, you know, it's partitioning in an OLTP system is fine. It's a huge boon. That's something that, you know, you will make that determination, definitely test, but Yeah, partition your OLTP environments if you think there's a benefit. At the very least, consider partitioning your indexes to remove or to reduce your maintenance windows and get you better stats, etc. But yeah, it doesn't need to be just OLAP.
Okay. So when performing a switch with disparate file groups, there is no metadata operations.
So the thing is, when you're switching into a table into a different file group, SQL Server literally has to select all that data out of the table and then do an insert. So you are paying a steep price. You are potentially paying a very steep price. And so no, it's not just a metadata operation at that point.
Okay.
Because a different file group is going to have different IAM chains, different data pages allocated. And it's going to be in a physically different file.
How do we implement a parent-child relationship on a parent table, or on a partitioned table?
The same way you would implement it on a normal table, on a non-partitioned table. I mean, all table partitioning happens under the hood. It's going to be transparent to your stored procedures, your queries, all those things.
And our last question is, will a composite index be considered aligned if the first key has the partition key?
So an index is only considered aligned when and if it is built on the same partition scheme. In other words, it doesn't matter what the keys are for the index. What matters is what is specified, or what partition scheme is used, and what column is used to partition the index on.
Okay, got it.
All right.
Well, if there's no further questions, I'd like to say a big thank you to Brandon for coming along today and talking to us about database partitioning. I'd like to thank everybody for coming along and joining us today. And if you haven't already registered, but we're up and running for next month. So I look forward to seeing everybody again in a month's time. Thanks, everybody.
All right. Thank you all.